Hello, everybody. My name is Mason Pessian. I'm happy to be here with all of you today and with all these tremendous companies. This is the CleanTech track of the 2021 SDIC Innovation Showcase. Hopefully you've caught some of the earlier great talks that occurred in the last 2 hours. And I hope you're all excited to observe a great slew of clean tech companies. Quick bit about myself. I'm a licensed patent attorney here at Wilson Sonsini. We have about 60 patent associates and patent agents here in the San Diego area, and we've always have a deep roots with the entrepreneurial and innovative community here in San Diego. And it's just great to see that despite these trying times, we're all able to meet and give all these great technologies the exposure that they deserve. And with that, we'll get into the first pitch. This is a company called Inersion, and they've developed a novel system for cooling and heating, for providing cooling, heating, and electrical energy. So with that, please.
Thank you so much, Mason. Hi, everyone. I'm Hanif Montezeri. I am co-founder and CEO of Inersion. We are originally a Canadian company who recently moved to San Diego, and we are hoping to expand in San Diego with all the support of the local groups and basically agencies that we are working with. Over the last few years, we've been supported by many organizations. We started from MIT in Boston and University of Toronto, and thanks to support of many organizations that has supported us, we have managed to innovate and develop a new type of chillers that produces cooling without using electricity. So basically what we have invented is a chiller or HVAC technology that uses heat instead of electricity to produce cooling. And the best part of our chiller is that not only it doesn't use electricity technically, it doesn't have any synthesized refrigerant. It uses water as its refrigerant in a closed loop system, and therefore it is categorized as a green alternative to all the traditional HVAC technologies that you have seen. We have more than 30 patents on the technology at this point. And I think the next question for you is that, all right, how does a chiller that uses heat instead of electricity could get integrated to a building? Let's go through an example. So let's say yesterday you bought a Tesla and your electricity consumption is going up. Then you decided to buy solar panels and install solar panel and produce your own electricity. So then you go and figure out that at the best case scenario, a solar panels give you around 20% electricity, convert 20% of solar energy into electricity. And then you are wondering what happened to the remaining 80% of the energy. The remaining 80% basically warms up the solar panel, and that heat gets dissipated away. So basically you're wasting around 80% of the solar energy away. So what we offer to our customer is an alternative scenario to this solar electricity generation. We offer to our customer a tri-generation system that gives them heating, cooling, and electricity. And the way it works is that you have a solar panel, we install hybrid solar panel. These hybrid solar panels, just like a regular panels, produce 20% electricity. However, they collect the thermal energy in the form of hot water, which around 70% of solar energy would be in the form of hot water. And that hot water would go to chiller, door chiller, and thanks to our innovative technology, we convert it to cooling. So during summer months, we collect all this thermal energy and convert it to cooling. And guess what? During winter months, we bypass that heat and we are warming up the building. So you would get electricity, cooling, and heating while you're harvesting 4 times more energy in compared to the traditional PV panels. And because of that, the overall payback period of this project is half of the overall payback of a traditional PV panels, which makes it very attractive to core customers. If you're wondering how does those PVT panels or hybrid panels look like, we don't manufacture them, we just simply buy it off the shelf. And they look like simply like a regular panels that you have seen on the roof of many buildings. The only difference is that there is a kind of piping going through there, and then basically warms up the hot water, and we collect that hot water for converting it to cooling in our system. This is how our technology look like. So our tri-generation that basically gets connected to the hybrid solar panel. It's a simple box that sits beside the building, on the roof, in the mechanical room, anywhere you want to put it. And it overall, it basically offers more than 70% reduction on your energy bills, because it provides everything for free from solar. And it's zero emission because we have no synthesized refrigerant or chiller, and use all energy from solar. So it's truly zero emission technology. If we're wondering how does the technology fundamentally works, we are using nanoporous materials. Around 6 grams of our nanoporous materials have the same surface area as entire football field. And because of that, we are able to replace the mechanical compressor in a traditional chillers, thermodynamic cycle of the chillers, with the nanoporous material that provides thermal compression. And because of that, we are using waste heat. We are able to use heat instead of electricity to run our chiller. As of now, we have more than $1 million in sales, and our current customers are office buildings. We are in conversations with few other organizations, hospital and hotels, and these are the typical organization that we make tons of sense for them, because they harvest so much energy. And the business model that we typically go after is that there is usually no upfront cost for a customer, and basically we tap into the cost saving that they have on a constant basis, and basically we generate revenue from that point. The total addressable market for us is, we think it's significant. It should be around $200 billion. And reason being is that we are basically are an alternative technology for solar panels. If you are deciding on a solar panel, we give you 4 times more energy and half of the cost of a solar panel. And that's why we think that we have a significantly large market capacity. And the original beachhead market for us, as I mentioned, is office building. The reason being for that is that energy cost is around 29% of the operational OPEX of an office building. And that's why we are getting quite of attraction among organization or energy managers who are managing these kind of assets. We have raised close to $8.5 million in non-dilutive funding. We have secured around $1.5 million grant and contracts and projects, and we are raising a modest $3 million fund because there are ways to match that fund. And the main reason we are raising is that we need to expand on our marketing team and expand on manufacturing team to deliver a customer. At this point, we are getting bombarded with so much customer demand, and we just need to fulfill our basically obligation toward our customers. The team started, as I mentioned, from MIT and University of Toronto, and since 2015, really, we expanded to 10 full-time people at this point, and we are expanding very quickly. I'm very proud of the team. Don't want to brag too much, but I have cherry-picked every single team member here. With that, I leave it to any possible question, and thank you so much for listening to our presentation.
Great, thank you very much, Anis. I actually had a question.
Sure.
Are you aware of your closest competitor? Is there anyone that's kind of doing anything like this out there?
There is one company that we know is in Europe, They have been working on this technology a bit earlier than us. Fundamental problem in that technology is that they are extremely expensive. And what we have managed is that we completely redesigned the entire system in a way that our technology is around 2 to 3 times more expensive than regular chillers. And that makes our technology financially viable. Or European competitors they are not financially viable in North America. That's why you don't see any implementation of them here.
Great, thank you very much. We have an additional question from the audience, and more directed towards the corporate structure. Is this a Canadian corporation or a U.S. corporation?
We do have a U.S. corporation and Canadian corporation, and yes, so but in U.S. we are using our U.S. incorporation.
Great, thank you very much for that.
All right.
If there are no other questions, think we can move on.
All right. Thank you so much, everyone.
Yep. Thanks again.
Thanks, Wissam. Have a good day.
You too. Next up, we have Ocean Motion, this company has developed the world's first adaptive ocean wave energy converter using artificial intelligence.
Okay, can you see my screen?
I can see your screen, Jack, maybe. Yep, there you go.
Perfect. All right. So good morning, everyone. Thanks so much for having me here today. So I'm with a startup company called Ocean Motion Technologies. And here we go. And we are a member company of CleanTech San Diego and the Southern California Innovation Network. And so the problem we're trying to solve is this. So we're trying to transition to more renewable energy collectively as a society, but even here in California, more than half of our energy still comes from non-renewable resources. And one way to bridge this gap is by having more renewable options, and ocean wave energy could be one of them. There's more wave energy on the West Coast alone than 2 times the California annual energy consumption. And ocean waves actually concentrate solar and wind energy, so they have a higher energy density. They are highly predictable with very low intermittency. And this is probably the most important part, in my opinion. It's underdeveloped. So if a project is successful, the return on investment can be a lot more substantial. But the real challenge is how to develop cost-effective ocean wave energy devices. We need to get the basics right, de-risk, validate, and build a viable business in small-scale market first, and then scale up to meet grid-scale demands. And this is a proven strategy in the solar and wind industries. But then the next question becomes, who needs a small-scale ocean wave energy device? So a few years ago, we were out at sea yet again for a routine maintenance service of these ocean data buoys to clean the solar panels and replace the batteries. And it kind of hit me, why are we using solar when there's plenty of wave energy? Now, this was back in 2015, and we didn't find any commercially available small-scale wave energy devices. So we thought, okay, this is something we have to do on our own. We also realized that we could leverage this intersection between clean tech and blue tech industry to develop wave energy technologies. Before I describe what we do specifically, let me just paint the big picture here. So the blue economy is undergoing a major transition to a big data paradigm like many other industries. There are lots of applications of big data in the ocean, and I'll just point out a few examples here. Better data on fisheries can prevent overfishing and also identify the location of schools of fish. Remote surveillance buoys can monitor illegal maritime activities. Better data from the ocean can improve weather forecasting. provide a better understanding of our changing climate, and even help in hurricane and tsunami detection and prediction. And this big data transition is achieved through cheaper and better autonomy and better network that get these autonomous sensors talking to one another. And we have fairly mature technologies for these first two categories because they were already really developed and teased out by traditional tech sector on land. But big data is still very expensive in the blue economy because we still don't have reliable, cost-effective power in the ocean. And all of these applications can be powered by our device using wave energy. And this is where we come in. We are fabricating a off-grid modular ocean wave energy device that's controlled by an advanced artificial intelligence system. And the device hardware can physically adapt to ambient wave conditions and optimize power output in a variety of sea states. And currently, most of our commercial partners we work with focus on small scale applications at sea. So like that picture you see on the top right corner. And so this means off-grid, low power applications in data buoys and moorings for ocean observation, maritime monitoring, offshore aquaculture monitoring, and surveillance for coastal security and defense. And with that, I just want to take this opportunity to thank the San Diego Innovation Council for having me here. And I also want to acknowledge CleanTech San Diego for encouraging us to participate in this event and for all of their support over the years. And we are very proud and honored to be part of this vibrant innovation ecosystem in San Diego. And that's all I have. Thanks so much for your time.
Thank you very much, Jack. Very interesting presentation, very relevant to not just today's times, but San Diego as well. Open the floor up to the audience for questions. I have a first one to kind of get it going. And is there an IP position here on this technology, or could you speak a little bit on that?
Yeah. So so the question is, the IP position and how we're dealing with it. What's our strategy? So most of our IP is tied into the mechanical design, the conversion mechanism. And yes, you can see I'm not showing any diagrams. We currently have embargo on this entire process, and we're actually filing IP. It's an ongoing process. So most of the IP is tied with the mechanical conversion. We also have an artificial intelligence control system, and that's treated as a trade secret. So in a way, our strategy is to separate the mechanical and the digital part. So in that sense, it's very hard to steal because those two are separated. So that's sort of our IP strategy for the moment.
Great, thank you, Jack. Being a patent attorney myself, I definitely appreciate you being cautious with what you're putting on your slides prior to the IP being filed. Not all my clients do that or let me know ahead of time. We have a question from the audience. What is the state of the product? What's the state of the development, the actual launching of the product? Do you have any customers? Have you done any market analysis, any traction?
Yeah, so we have done very detailed market analysis. The market condition is great for this technology. Especially because I am an end user myself as oceanographer. We also have a very long line of customers that are demanding this product, and we're very close to a minimum viable product. We're going to do a pilot demonstration with a customer in early 2023. So we're getting really close to having a product in the water.
In the water, great, thank you. And perhaps I missed this, but how's your current, to the extent it's not confidential, the current fundraising history for the company?
just really quickly, non-dilutive funding, all based on research grants. We're primarily funded by the Department of Energy's Powering the Blue Economy initiative through the SBIR programs.
Great, great. Well, I asked my questions, and I think so far no other questions from the audience. You have another minute if you want to give us any more information.
I thought I was running all the time, but yeah, I think San Diego is a great place for this type of development. It is really at the intersection of blue tech and clean tech, and we're really happy to be here. And we appreciate your support, and please follow us on various channels and follow our developments in the future. Thanks.
Thank you. Thanks again, Jack. Great presentation.
Thanks.
All right. Next, we have Smartville. This company has developed a platform to generate second life applications for electrical vehicle batteries. And with that, I'll pass it over to Trish.
Great. Can you see my slides, Mason?
I can.
Okay, perfect. Hi, everyone. Thank you for having me here. My name is Trish Tran. I am currently working as the project manager here at Smartville. I am very excited to be speaking about a topic that is literally driving the future of renewable energy. And it just so happens that I'm working for a company that does just that. So stationed in Carlsbad, California, Smartville is developing technologies to repurpose retired electric vehicle batteries in a second life, which brings value back to those batteries and the supply chain. So how we actually do that, I can get to it in a bit. So Smartville is targeting the market opportunity from the rapidly growing adoption of EV, with more and more electric vehicles hitting the road every day. Millions, over the next decade, millions of EV batteries will be retired worldwide. So much so that a 2019 study estimated that retired electric vehicle batteries could well exceed 200 gigawatt hours of the annual global supply. So because of this, Smartville is developing technologies to utilize these retired batteries and provide low cost and highly reliable energy storage solutions for homes, businesses, and the electricity grid. So this will bring benefits to both the transportation and the utility sector. In traditional battery second use approach, you can see that EV batteries go through multiple stages and possibly at multiple different facilities to undergo inspection, testing, assembly, storage, before it can actually become a second life product. This traditional route of repurposing EV batteries has high carbon emissions for transporting from facility to facility, and even higher costs for equipment, for labor, and warehousing. So our solution is to develop distributed hubs to provide an efficient end-to-end solution for battery repurposing and recycling. These hub facilities will service, manage, and reuse EV batteries, but more importantly, it will streamline the traditional EV battery repurposing method by having everything done in one, all-in-one. The hub facility will reduce shipping and transportation costs by acting as an all-in-one sorting, testing, integrating, and storage site for retired electric vehicle batteries. So we used advanced power stages and life balancing control system to integrate these retired batteries. This allows us to balance and condition the batteries to improve their uniformity in performance and maximize their life cycle value to ensure a safe and reliable second use product. So at the same time, the hub facility itself will also provide valuable grid services to offset operational costs and bring in additional revenue. So not only will our end-to-end solution inject efficiency into the lithium-ion battery supply chain, but also empower a new circular economy of zero carbon energy and electric mobility. So with the life balancing control algorithm, we can effectively extend the retired battery's life by more than 30% through establishing this unique dual use facility and a pipeline of second use batteries. The hub solution can provide grid energy storage at 50% cost reduction. And finally, the hub facility also acts as a pit stop to collect and prepare batteries for recycling, so targeting over 90% of the recycling rate. Just taking a short look through our company's timeline, it highlights continuous local engagement and support. So in early 2019, Smartville spun off from a UCSD research lab. We were then fortunate enough to be awarded with the CalSeed Business Development Grant and admitted to the Southern California Energy Innovation Network. Shortly after that, Smartville was the only California company awarded with the phase 1 and phase 2 of the DOE Battery Recycling Prize. And we're currently competing in the final phase right now. So through partnerships with UCSD and local industry partners, Smartville is a key contractor and sub-recipients for multiple California Energy Commission projects. So our project demonstration sites vary across California. For each project, we want to showcase the wide variety of use case applications, such as behind the meter charging and front of the meter grid services. This allows us to gain market exposure while performing market validation. So throughout all of our demonstration projects, Smartville is testing our own ability to provide EV batteries with an efficient and a cost-effective second life, but at the same time, testing the capability of the EV batteries themselves and see what kind of value a battery's second life can provide to the customer. The San Diego Innovation Network itself has introduced us to multiple research opportunities for state and federal funding. They also introduced us to a few business development groups where we performed use case analysis to narrow down our market entry. And the network has also connected us to numerous local municipalities and businesses, many of which have become our key partners in our demonstration projects. So our company and its technology proved to be beneficial to stakeholders by addressing key supply chain risks by improving grid resiliency and renewable integration, by empowering modern electrified transportation, and by building facilities that will employ and train America's future skilled labor force. So moving forward, Smartville's main goal is to contribute to the circular economy of lithium-ion batteries. We hope to do that by maximizing the life cycle value of EV batteries and then eventually feed to the material stream through recycling. So with that, I would like to thank everyone for listening to my presentation, and then I can take any questions or comments if anyone has any.
Thank you very much for the great presentation, Trish. It's always great to see the commercialization of technology coming out of UCSD. I'm sure a lot of people in this audience, including myself, have strong ties with that great institution.
Right. Sure.
Quick question from on my end: is there? How do you anticipate getting all these batteries? Is it going to be like are you going to influence, users to just don't, recycle? It's like going to be like a recycling program, or what's the thought process there?
Right. Our main focus is to partner up with OEMs or original equipment manufacturers themselves and build a relationship with them and eventually become a partner with all of these companies, and where they, would send us batteries for repurposing and recycling instead of leaving it in a landfill or sending it to somewhere else.
I have a quick follow-up on that, but someone from the audience is asking, is there novel technology that you've developed to enable these to enable this repurposing, or is it more of very good logistics?
Right now, our first, let me see if I can. So our first second use product is our Moab. It's the modular assembly battery. It is the energy storage unit that is going to be taking in all of these used and retired EV batteries. And then we pretty much integrate them and condition them so that they are working as a storage or stationary storage, and pretty much using the remaining life cycle that is already in those batteries.
Got it. Do you have any IP protection on any component of this?
Unfortunately, in my current position at the company, I don't think I have any knowledge about the IP, but I'm sure, or I know that we are currently working towards gaining IP, and yeah.
Great. Okay, and thanks again for the total presentation, Trish. Really, hoping this comes to fruition. This is great. Next up, we have TieFast, that along these same lines, creating long-lasting, fast-charging lithium-ion batteries.
Thanks, Mason. Can you guys see my screen?
I can.
Perfect. So hi, I'm GJ, co-founder and CEO of TieFast. Before I start, I wanted to thank SDIC for the opportunity to share work at the company, and also want to share our deep San Diego roots. So we are currently a San Diego-based company. We are a recent spin-out of UCSD and Professor Ping Liu's lab at the Sustainable Power and Energy Center. We're a member company of CleanTech San Diego and a participant of the Southern California Energy Innovation Network program. So after all these years, lithium battery performance still falls short. For mainstream graphite-based lithium batteries, the ones that power your laptop, your phones, primarily all EVs today, these have short cycle life, roughly 1,000 to 2,000 cycles. These systems require long charge times, 30 minutes or more, to actually preserve cycle life, because fast charging them degrades battery life. In addition, these systems actually need to improve on battery charging safety. Today, these batteries need to charge above freezing in order for them to avoid lithium metal plating issues and faster battery degradation. So our solution at TieFast is to set a new performance standard with these battery platforms, delivering 20,000 full cycles of life. That's 10 to 100x longer or more cycles. Enable fast charging down to the minutes level, single digit minutes level. That's 10 to 20x faster than current batteries. And then also enable charging safety down to minus 30°C. That's now matching the entire discharge operating window. So there is no limitation on how fast or what temperatures one operates for charge or discharge. It's now a symmetric operating space. So we're able to do this because of this breakthrough LVO anode material developed at the UCSD campus. It has three key properties that enables this new performance regime. First, it has lower expansion, making the electrode more stable over cycling, enabling this long cycle life. The second is it has faster lithium transport, allowing charge and discharge to happen faster, enabling this ultra-fast minutes level charging regime. And then it also operates at a safer voltage, further away from lithium plating potentials, allowing you to charge at lower temperatures and also at faster rates. This is actually a new materials discovery for lithium battery anodes. So what we've been able to do, which is unique, is actually file 3 broad material composition patents. Unlike many other technologies that are out there, which are in some cases focused on engineering or design of the electrode using existing materials. To date, we're still in the lab. We're working on single layer battery cells. However, we've already demonstrated 15,000 cycles on this anode material and capacitor like 20 seconds charging to 40% of the anode capacity. And this is all now using industrial grade vanadium oxide. Vanadium oxide is the raw material for this novel anode. In previous work, we've used high purity or lab grade vanadium oxide. Now we're actually sourcing the rest directly from commodity markets. For battery manufacturing and scaling, we plan to basically just do a replacement of graphite in existing lithium batteries today and putting in our LVO anode to unlock this performance. Finally, on the science side, we've been featured by the DOE, as well as peer-reviewed, extensively peer-reviewed. So we know that the science for this particular material works. So our go-to-market strategy is focusing on revenue grade, high duty cycle, and autonomous applications. We believe this is the battery to power the always-on, fully autonomous future of business and mobility. We'll first launch with smaller scale robotics, materials handling, logistics applications, and premium micromobility. This will allow TIFAST to demonstrate our technology at commercial scale. Once we're there, we can then start to do electric vehicle validation and testing for integration into future autonomous passenger and commercial EVs, as well as battery support for EV charging stations. So why this two-phase approach? We believe this is actually ideal for commercializing a brand new anode material technology. So first, the launch markets have smaller battery cells and battery packs, allowing us to produce these cells sooner versus very large scale battery cells and packs for the electric vehicle markets. Second, on price, these battery packs actually command premium pricing, 2 to 5 times more per kilowatt hour at the pack level versus the scale markets, allowing the company to actually be gross margin positive sooner. Third, the validation type is significantly shorter. Within a year or two, we can onboard our technology onto these product platforms versus up to a 4-year validation period for larger scale markets. Finally, because we're enabling fast charge with our battery systems, the fast charging infrastructure at these small scale launch markets is basically your wall outlet, your 120 volt wall outlet, or your 240 volt commercial grade outlets. So it's readily available today. One can actually fast charge these systems without any issues. Unlike fast charging for very large scale EV systems on the demo side or a bit more on the infancy side. We've also received positive traction from these potential launch customers, and I'll highlight a couple here. A leader in warehouse robotics has basically said that our batteries are 4 to 5 times better than standard lithium ion. And here's why. They can cut the battery pack in half, so volume and weight in half. They can deliver 2 times faster charging and double the work to charging ratio. They're interested in testing our batteries as soon as it's available in commercial scale. An innovator in the wireless charging for mobile robotic space has basically said these robots need really long lifetime and really high rate charging. And this is exactly the battery that TIFAST can deliver. For the micromobility or personal electric vehicle space, we've had similar positive traction where now these manufacturers can actually, we can enable them building the lightest, sleekest, and safest fast charging vehicle, personal electric vehicles for future markets. So here's our business model. We will directly sell our battery cells to those identified customers. How to get there? We will make this proprietary anode material ourselves to protect and control the IP. We will provide that anode material to battery contract manufacturers, both in the cell manufacturing as well as in the pack assembly, and then deliver those final cells and packs to the end customers identified. Here's our team, highly qualified, 40 years experience in both batteries, R&D, and commercialization experience. Myself, I spent 10 years at Primus Power scaling up innovative stationary flow battery systems to early commercialization. My CTO, Dr. Haodong Liu, is a co-inventor of the tie-fast anode and a project scientist at UC San Diego. Professor Ping Liu is a co-inventor of the anode as well and has spent 20 years in industry and government. This is my last slide. Our company is launched. We have strong value proposition with launch market customers that want to test our batteries as soon as possible. We're incubating at UCSD's Sustainable Power and Energy Center. And currently we're seeking funding to accelerate multi-layer battery prototype demonstrations. Feel free to reach out to me. My email's below. Thank you.
Thank you, GJ. Incredible presentation. A lot of thought put into your go-to-market plan, and very, very much appreciated, certainly by me at least. I'll open it up to the audience for any quick questions. As far as my typical questions about competition, IP, and market traction, I think you've already kind of covered those, GJ. Is there potentially a competitor that you know about that is potentially using some similar ancillary some related technology, or is there any analysis on that?
Yeah, so competitors currently are bucketed in high energy batteries that charge slowly and last for shorter cycle life, and then fast charge batteries, which basically want to charge in a few minutes and effectively deliver a long cycle life. So competitors sort of circle us around. However, with this new material innovation, what we've been able to do is actually maintain the high energy while delivering both fast charge and long cycle life. So we believe we actually carved out a sort of a new niche, a new space, opened up a new really canvas, opened the canvas for battery performance. There are technologies out there that are based on titanium, niobium, or silicon that are trying to achieve the performance levels we've had, and that's what we try to improve upon.
Thank you. So great presentation again.
Thank you.
Very great stuff. We'll move on to Brixpo. Brixpo is simplifying the development of novel clean energy technology infrastructure. And with that, I'll pass it on to Cameron and Benjamin.
I'm Ben. Together with my co-founder Cam, we've created Brixpo. Our aim is to accelerate the adoption of novel renewable energy technologies by simplifying their deployment through a stackable energy storage, conversion, and distribution system. So our modular architecture built on 1 kilowatt modules can scale up to meet the demands of a bunch of applications while reducing their setup time and design cost, all with no engineering expertise required. And this sort of product can apply across a very broad range of industries, from government level to industrial level down to consumer level. And we've decided our beachhead market to be the consumer level van and RV market. And Ken will get into why.
So like Ben said, we've identified the van life as our starting market. First off, there's virtually no regulatory barriers when setting up an electrical system in a van. There are also not that many products that target the van life specifically. And then lastly, we've seen upfront how friendly everyone is in the market, how willing they are to meet, try things out, overall have a positive attitude for a young startup like us. Overall, this market provides us with a sandbox for us to prove out our technology before we transition into other markets. So van life is trending as high as it ever has right now. A big reason for that is COVID has shifted the way consumers view travel. People are thinking twice about getting on an airplane, staying at some big resort, and they're reevaluating ways to get out of the house. Camping and van life exploded during the pandemic, and the numbers don't lie. Mercedes Sprinter's van sales rose 26% in 2020, more than any individual year in the last decade. As a whole, the renewable energy generation is only starting, and we're seeing rapid adoption of these clean energy storage systems and overall healthy growth in these sustainable technologies. So taking a closer look at the market, we found that the RV market can be broken up into two segments, that being van life and then traditional industry companies like Winnebago. We project there's about $180 million and $280 million spent per year, respectively, on just the electrical systems in these vehicles. We decided to focus first on van life because of that lower barrier of entry. And you can see this market can also be broken up into DIYers, mid-range van outfitters, high-end. We went and interviewed all of these different segments, and we ultimately decided that DIY and mid-range were the ideal beachhead market for us. Overall, we plan to dominate this niche market and then expand outward into larger markets like home energy storage, with the goal in mind of becoming a large-scale energy company. So now I want to give you some context for what a traditional electrical system in a van is like. There are many discrete components and you need to think about when setting up the system, such as what type of inputs do you want? Do you want solar? How much? How many converters are you going to use? Are you going to connect to the alternator? What type of batteries, inverter? These questions can go on and on. And we can see that there's a lot of wasted time that can go into trying to answer these questions. So we went out and interviewed a lot of members of the DIY community as well as owners of van outfitting companies. And we found that between these two segments, they seem to have similar yet slightly different problems. Almost every single DIYer we talked to had no experience with electrical systems. So setting one up was a huge challenge. On the other hand, van outfitters do have experience with these electrical systems. However, they're in the business of converting as many different types of vans as fast as they can. And the biggest problem for them was, even though they knew what they were doing, it still took a long time, on average 2 days to a week. They also had to deal with sourcing different parts, packaging it all effectively. And then on top of this, the most common problem for both markets is that once you go through this whole process of setting up the electrical system, it's a fixed capacity. You can't change the capacity without serious engineering.
So our solution addresses all the problems Cam just mentioned by putting each one of these discrete devices into a single box. This reduces the part count, cuts install time, and basically turns the electrical installation into a plug-and-play system. Our solution can interface with the 3 common input power sources, being grid, solar, and the car alternator. It can store that energy in a battery that's inside the device, and then it can output to AC and DC appliances. Not only this can stack together to increase both energy storage and power output capacity, so that if you are just a weekend warrior going out camping, one module is adequate. If you're going on a more heavy road trip and need a little more energy storage, 2 modules will do fine. And then if you're living in it full time, you need AC, heating, water pumps, and a refrigerator, other things like that. 3 modules will be adequate.
So there's definitely other all-in-one energy storage systems on the market right now, but the biggest differentiator is that none of them can stack together. Another important distinction is that we're the only company that's specifically targeting van life, and thus we're creating a product that answers all of the questions that are specific to this market. So far, we've been working on the prototype for the last 6 months. We've also been actively reaching out to van outfitting companies, getting letters of intent, and establishing these channel partnerships. Once we complete the prototype, our plan is to reach out to these partners and demo the product with the goal of gaining traction, securing provisional purchase orders that will ultimately help fund the further development of our product and give us the opportunity to have our soft launch with just the van outfitting companies. Assuming that all goes well, we'll fully release our market-ready product to all of van life, such as the DIYers.
So that go-to-market strategy essentially covers the first 2 steps of our master plan, which are low-volume prototype to prove the market need in the van space, followed by medium volume premium product for mobile storage applications, including vans, RVs, as well as trucks and boats. And then that would be a stepping stone for our later plan, which is a high volume premium product for home energy storage, with the ability to pull these modules out and actually use it to power small electric transports like bikes and scooters, as well as to use on the go as mobile energy storage. Finally, high volume, inexpensive product to aid in various sectors, manufacturing, medical, disaster relief, and things like that. So my background is electrical engineering. I have a physics minor as well. I'm the lead engineer on the project. Cam has a mechanical engineering background with an entrepreneurship minor. We graduated 2 years ago, so we're pretty new onto the scene, but that's why we recruited our contract engineer, Charles, who is a retired principal engineer from Collins Aerospace with 35 years of experience designing electronics. We also have a really good slew of advisors spanning software development, manufacturing, business, as well as specifically power electronics, and they've been instrumental in helping us design the product as well as develop our business.
So far we've spent about $30,000 building our business. 10,000 of it has come from non-dilutive grants from the SDSU Zip Launchpad, and then we've put up about 20K of our own personal funds. A large majority of this money has gone towards prototype development. We also have a provisional patent and also other business activities. What we're projecting right now is it's going to take about an investment of about $500,000 for us to get enough runway to get our market ready product developed and our company ready for an addition or the launch in 2023. Just a quick thanks to the partnerships that helped made this possible, such as Southern California Energy Innovation Network, CleanTech, SDSU Zip Launchpad, as well as our advisors. Thank you all for your time. If you have any questions, feel free to let us know. If you're interested in working with us, feel free to reach out to our contact information here. Thank you. I think you're muted, my son.
Great presentation, guys. Thank you for that. And I definitely have felt the move to people moving around a lot more. I can't tell you guys how many calls I've been on where someone's coming in from some sort of like van in Yellowstone. There is a question from the audience. Are there any government approval measures required, including safety? Does this add or reduce capital or operating costs to a do-it-yourself or custom van house?
So right now, our product would be classified under consumer electronics. So we have to get UL certified, FCC certified, but those are really the only certifications that are required on a commercial level. We're not interfacing with the grid in terms of putting power back into the grid where you'd face more regulations. So it's a pretty simple product from a regulatory standpoint, which is why we chose the van life market to start out in.
Got it. Makes perfect sense. Okay, if there are no other questions, thanks again, Ben and Cameron. Great presentation.
Thank you.
Thank you all.
And last but certainly not least, we have Rejule. Rejule has developed a next generation battery diagnostic platform to help usher in an even more sustainable electrical future. And with that, I'll pass it over to Rejule and Zora.
Hi, thank you. Let me go ahead and share my screen. And I just want to make sure that if it's sharing the right version, sorry. I don't think it's sharing right now, right? Sorry.
No, we are not seeing your screen.
Let me get this done.
There we go.
Okay. All right, great.
Perfect.
Sorry about that. All right, great. So hi, everyone. I'm Zora Chung, the co-founder and CFO at Rejule. And our mission is to maximize the value of every battery with our fast battery diagnostics platform. So this may surprise you, but automakers actually don't have a good way of tracking the health of the batteries that power an electric vehicle, or EV. Their vehicle health predictions is based on testing done in the lab, and this methodology gets less accurate over time. We've seen a case where the prediction was off by 15%. This inaccuracy is driving $8,000 in unrealized sales from lower residual values and lost repurposing revenue potential. Automakers are starting to reach out to us to get a more accurate benchmark to calibrate their battery algorithms. This is because Rejoul's diagnostic platform is a fast and easy to use health check, which includes proprietary hardware, software, and algorithms. Our system innovates on a proven technique to characterize batteries called electrochemical impedance spectroscopy, or EIS for short. The technology can work on any chemistry, cell type, and battery pack configuration as long as we can connect to the battery. Our IP strategy is a combination of patents and trade secrets. Of our 2 patents pending, we've already filed an international patent application for the hardware, and the second is a software to handle real-time signal processing. We've also developed proprietary machine learning algorithms for our battery modeling. We've raised over $4.8 million in non-dilutive grants, which has funded the development of our MVP to an early beta. And we're working with UC Riverside to provide third-party testing to further de-risk the technology through the Cal Testbed program. Next, we have our paid project and a letter of intent pending with a top 10 automaker. In addition to our grants, we're also part of various accelerator and startup programs. And I want to take a moment to thank our mentors from the Southern California Energy Innovation Network for this opportunity today. We've also won some global industry-specific competitions, including the EV and Battery Challenge, hosted by LG Chem and Hyundai. And earlier this year, we were a winner of Global Automotive Mobility Innovation Challenge, known as GAMIC. This was sponsored by the Society of Automotive Engineers, and judges included companies like Ford and Denso, a Tier 1 automotive supplier. Our solution is best positioned to address the needs of the automotive industry because we're the only one that offers fast and accurate testing for the high capacity and high voltage batteries that are used in EVs. Status quo is to cycle the battery, which is to charge it up to 100% and drain it to 0. But this is not scalable because it will take hours for one data point just for one EV. Software-based solutions are scalable, but they use the same data as OEMs, so there is no real improvement in accuracy. Furthermore, to train these models, you need tens of thousands of data points. Rejoul has already performed 3 case studies where we were able to get within 3% accuracy of the status quo with just 50 samples. And of course, there are hardware-based solutions that enable fast and accurate testing, but they are limited in their ability to scale up to automotive-grade batteries. Rejoul has already proven our solution works with car, forklift, and even larger truck and bus batteries. While there are many use cases of our technology across the battery's life cycle, we've narrowed down to these early target customers and use cases. Automakers like GM and Nissan want to leverage our measurement as a benchmark at their service centers, where a battery diagnostic can be as fast as an oil change. Companies that manage fleets of vehicles like Penske or Hertz wants to be able to enable preventative maintenance so they can reduce their unplanned downtime. And used car sellers and ratings companies like Insurance Auto Auction and Kelley Blue Book are seeking new ways to calculate residual value by actually factoring in the battery's health. Now I'm going to walk you through one example of how we would work with these early customers. We have 2 contracts pending with a top 10 automaker. The first is to provide fast grading of their used EV batteries for repurposing with our existing tester, which is the black box on the screen. In the past year, this tester has already graded over 1 megawatt hours of used batteries. Repurposing these batteries is the equivalent of taking a car off the road for about 2 months. But there is over 50 megawatt hours of used batteries to grade in just the next 2 years, which will take almost 8 cars off the road for a year. This exponential growth in retiring EV batteries and increasing regulations governing the responsible management of batteries at end of life is driving automakers to quickly find solutions to repurpose and grade their used EV batteries. The second is a co-development project with a letter of intent pending for in-vehicle battery tester that would plug into the vehicle's charging port to access the battery. The end goal is to use our product at their service center so they can perform battery health checks to better manage warranty costs and assess the residual value for their used EVs. Ironically, we refer to our business model as GaaS, grading as a service. Pricing will depend on the number of tests and battery types. By focusing on those variables versus selling hardware, this will allow us to scale with our customers as more EVs are on the road. Using the automaker as an example, this can be sold to their service center as authorized diagnostic equipment. Each service center will have its own subscription model where our revenues will grow as more tests and hardware units are needed to support the growing number of EVs they will be servicing. The size of the diagnostic market is driven by the number of EVs on the road. Assuming we charge each service center $150 per test, when vehicles get tested twice a year, the market size is the number of EVs times 300. So for 2020, that opportunity was already 2.1 billion globally with 510 million in the US. Keep in mind, half of that opportunity is in California, where Rejoule is headquartered. Based on EV sales projections, in just 4 short years, that number will triple to 1.5 billion. And keep in mind, these numbers are just the tip of the iceberg because EV sales are expected to continue to accelerate over the next few years. We have done everything in-house with our team of engineers led by Rejoule CEO Stephen. He has a master's in electrical engineering from the University of Toronto, and he previously worked in the defense industry where he designed and tested military-grade power systems for Navy ships and submarines. He is also a technical member on a few standard boards around battery management systems and testing. Stephen recruited me to lead the business side because I have over a decade of experience optimizing business models from established companies like Clorox and Walmart. We're also supported by an amazing group of advisors that bring extensive experience across the automotive and battery industry and have experience in technology startups where they had to scale from teams of less than 10 to hundreds. We plan to raise a 3.5 million seed round that will unlock an additional $500,000 in non-dilutive match funding from the National Science Foundation. We're looking to secure $500,000 from angels before the end of this year, and we've already secured almost half of that in soft commitments from friends and family. The seed round will help us scale because we will be able to secure 24 months of runway until our Series A, create a patent portfolio that will be important for our exit strategy, accelerate our product development from MVP to beta, and launch a pilot to prove our value and grow our data moat so that we can establish our first mover advantage in the diagnostic market. Thank you for your time, and I hope you will join us in our journey to maximize the value of every battery.
Great. Awesome presentation, Zora. Just to wrap up, as I mentioned, a great slew of clean tech companies. Very impressive. Not seeing any questions coming in, so I think we can go ahead and wrap this track up. Thanks again to all the companies that presented. This was very impressive. Excited to see what the future holds. Thank you for all your time in the audience, and thank you to all the panelists for your time in pitching.